Any other track who is having any important issue which is running and on which they are working? Just one more information, maybe right now I have not got the info till now, but Sunny may also be joining this call as he has asked on last Friday. Okay. Sushil, how are the SharePoint servers? Are they fine? Backup, Lalit, anything from your side?
Sir, I'm facing some issue while taking the RDP. 1 minute, what else? The user account is currently disabled and cannot be used. But like some time back, I was taken some RDP of few servers. And at that time, I was able to take, but now.
Yes, sir.
Getting the user account is currently disabled and cannot be used. So,
last month there are a lot of issues due to network problems. So, just going through the slides, if you are not able to understand any slide, just end. Okay. So, what you have discussed in the previous class, then from here I have started again.
Raju, which server it is?
So,
any problems?
S-mid-match.
Raju, which account you are using to log in?
Yeah, my account r.com.
So better to need to check with GAM team or either by AD team.
Means with some time back I was able to most of these servers. Okay, but right now when I trying to again RDP, it's not working.
No. I mean only for this server or a couple of servers. There is a couple of servers means need to be checked by GAM or either by AD team.
Because I'm doing the LC, that's why I'm taking the RDP one by one.
Yes, need to check with AD team or GAM team.
Oh, then I will drop my mail with the error.
And from storage and backup side, we have a meeting around 8:30 IST with Jitendra. Also working on 2 changes for service leading and real upgrade on AX.
Any doubt on department, identity and liability?
স্যার কয়েকজন জয়েন করতে পারছে না।
So, what I have told in the last class that database designer you have to choose one key as one attribute, one or two attributes as primary key. Okay, so database designer will choose one or two attributes as primary key. One, two, or many attributes as a primary key. Okay, so in the employee relation, suppose SSN is a primary key that is chosen by the database designer. Okay. Now, there are some constraints. Okay. When you are specifying a key, primary key, there are some constraints associated with the key. Okay. So suppose in a card relation, license number is chosen by the database designer as the primary key. Okay, so license number is the primary key of this relation. Okay. Now, what is the main constant? That the license number of all tuples must be unique. There will be no repetition. Primary key value must be unique in a table. Another constant is that primary key value cannot be null. The first constant is primary key value must be unique and the primary key value must not be null. Okay. Must not be null. So, entity integrity, relational database schema, a set S of a relational schema that belongs to the same database. S is the name of the database. Okay. So, in a database there are several relations. Okay. So, S is the name of the database and relations can be denoted by means of R1, R2 up to Rn. That is known, that is relational database schema. Okay. So earlier we have seen that the relation, we have seen the definition of a relation. Now, many such relations together will form the relational database schema. Okay. So if you take many relations or many tables together, that will form a database schema. So in a database, there are many tables or many relations. Now, entity integrity, the primary key attributes, primary key, EK, of each relation schema R in S cannot have null values in any tuple of RR. What I have told, that in a relationship, in a relation, if a attribute is chosen as a primary key, that attribute cannot have null value. Okay. So for any tuple, primary key value cannot be equal to null. Okay. Okay. So that is known as entity integrity. That is one constant that you are putting by choosing something as a primary key. Okay. So one constant that I have told, one constant is that the value must be unique. Second constant is that primary key value must be unique, and second constant is the primary key value cannot be null. Okay. Now, the differential integrity, the constant involving two relations. Now, the primary key constant involves only one relation, but this differential integrity constant, that constant involving two relations. Okay. The previous constant involves a single relation. Now, used to specify relationship among tuples in two relations, the referencing relation and record relation. So there are two relations or two tables. One table is referencing others. So referencing table and referred table, or referencing relation and referred relation. Two tables are there or two relations are there. Now, tuples in the referencing relation R1 have attribute foreign key Fk that references the primary key attribute of the referred relation R2. Okay, a tuple T1 in R1 is set to refer to tuple T2 in R2, and this must be true. T1 Fk equal to T2 Pk. That is the foreign key value of one relation will be same as primary key value of the second relation or any tuple. Okay, so that is known as another type of thing, that is referential integrity. Okay. Now, a referential integrity constant can be displayed in a relational database schema as directed arc from R1 Fk to R2 Pk. Okay, so there will be an arrow from this foreign key to the primary key. So R1 is the referencing relation and R2 is the referred relation. And there will be an arrow in between these two attributes. Foreign key of the referencing relation to the primary key of the referred relation. Okay. Now, referential integrity constant, the value in the foreign key column of the referencing relation R1 can be either a value of existing primary key value of the corresponding primary key in the referred relation R2. So, foreign key values may be any values of primary key of R2 relation. 1 minute. Hello. Oh, yeah. আমি নটা পরে করছি, আমি একটা ইয়েটা মিটিং আছে, হ্যাঁ আমি পরে করছি 25 তারিখে নাম্বারে, হ্যাঁ আমি ওই নাম্বারটা দিব, নটা পরে করছি। Okay, so the foreign key may hold a value from any value of primary key, and it cannot be now. Okay. In case 2, the foreign key in R1 should not be a part of its own primary key. Okay. So the thing is that foreign key value must be any value from primary key of another relation, or it can be now a noun value. In case 2, the foreign key R1 should not be the part of own primary key. Okay. Now, other type of constant that we cannot put in the schema. So, semantic integrity constant based on application semantics and cannot be expressed by the model. That is, suppose one constant is that maximum number of words per employee for all projects he or she works on is 56 hours per week. That is one constant. Okay, so if type of constant that you cannot put into the model. Okay, so this is semantic integrity constant. These are not under referential integrity constant or simply integrity constant. Okay, so a constant specification language have to be used to express this. In SQL 99 allows triggers and assertion to allow some of this. Okay, so later in the lab, we can see that we can apply triggers and assertion to implement this type of constant, semantic integrity constant. Okay, so these things we cannot put into the model, this type of constant. Okay.
Sir, regarding this cipher algorithm, we are working with Monolith. So we are planning to implement that in next weekend, means in Sunday.
In the year diagram,
for that issue regarding control.
Various entities. Okay. We can express this entity in terms of we have to convert this entity year diagram into relational model,
and we are going to do it
in terms of relation. Okay, so in relational model, the database can be expressed in terms of relation, many relations. So what we have to do, we have to convert this ER model into relational model. Means we have to convert everything in terms of relation. Relation means here it is table,
last week that
but in the
all of you
ER model it is relationship.
need to
So the relationship in the ER model and the relation in the relational model, they are not same.
Identify the cause for that.
Here in the entity relationship model, the relationships are relating two entities or three entities. But in the relational model, relation means a table. Okay, so don't become confused.
I do have some concern.
Okay, so what we have to do, we have to convert this ER model into relational model. So the relational model means lot of relations. See, we can get these relations with these tables. So on these relational ER model, we have to get this table, get this model.
We need to the physical
And
increase on every
how to do so? Means how you can convert these ER model
Yeah, that I already told in the initial
relational model.
to check on that.
Okay, earlier we have seen that how you can convert a problem statement into ER model.
That will be the question
Then
coming
next step is to convert this ER model into relational model.
Receiving for that what we are doing on that.
So in this
I
chapter,
already
we will
informed
discuss
Lalit to
those
work
things.
on that and
How you can convert
increase the
A
if that is
ER
the only
model
option
into
to
relational
do
model.
that, then we need to
Okay.
work on that only.
Now,
until unless the memory will be increased on the server,
so
we cannot
suppose
give more memory to the Oracle database.
here
And
we are having
receive the
entity,
like
one
1,000
entity, entity type,
every day.
that is employee.
And
Okay.
the root cause
So
of
we
that
can put
memory
all
storage on the
employee
server.
data into the employee table. So what we have to do, we have to create an employee relation. Okay.
Yeah,
Now,
Rajiv, you can do
suppose
one
this is
thing,
the
you can
employee
raise a
relation.
problem ticket for that. Let's
Okay.
raise a
And what I
problem
have
ticket
told
and
that
then work
in a
on it.
relation, one or two
Problem ticket
attributes
I
will
will
be
raise for the
chosen
unit
by
server.
database designer as primary, and
Like
that
your
attribute
teams
must be
will
unique.
you will also be
That
there,
attribute
your
value in this
both will
table
work
must be
together,
unique.
but mainly
Okay, so
first
all
we will
employees
increase,
have
then you will
unique
increase on
SSN
Oracle
number.
side.
So SSN can be
That
used
is the
as a primary
solution for that, but
for
let's
this table.
raise a problem ticket and let's do it through a proper
Okay.
process manner.
For this table.
So, okay, we initiate the problem ticket and assign to the unit step first. Okay.
Okay.
Yeah, problem
So
tickets
SSN
are
is
not
the
like
primary.
that. It will be
Similarly,
assigned to
for
any
the department
particular
table,
team. I think
department
Rajesh
number
will
is the
be
primary.
sending the email.
Okay,
It
for
will
the
have
project
all the
table, project
team
number
names
is the
who will be
primary.
working on that,
Okay.
and the update will.
So in the dependent table, ESSN and department number, department dependent name together is the primary.
And then to you when he will do the things.
Okay.
Okay, I will take the help.
Now, in the department location relationship, department number and D location together is the primary key. Works on ESSN key number together is the primary key.
Yeah, Abhishek, anything from SCCM side?
Okay. So, if SSN is the primary key, the value of SSN is unique, one thing. Another thing is that the value cannot be null. For any tuple, the value cannot be null. So these are the constants that we have put.
Now I have deployed on Kenosha.
Okay. And apart from that, I have discussed about foreign key. So the foreign key relating to tables. Okay, suppose this is one table, employee table, SSN number, and works on is another table or another relation with ESSN number.
One
So
requirement
ESSN
for, like for that
from the
party
this
patches of
ESSN is referencing this SSN. That is the primary key of another table.
not only for
Okay.
Java,
And this ESSN value
Chrome
can
and
be
in that
any
document
value
whatever we do now.
that is already there into the employee
Not a
table.
brief detail, not
And
a, like extensive detail, but a short description
It
of
can be null
how we
value
are handling.
if
In case we are not
ESSN
handling, then
is
we
not
will
the
write
member
that,
of
this
this
right now.
primary key of this
Discussions
table.
are going on.
So in this case, as ESSN is the member of the primary key,
Like for
so
Adobe, they have
its value cannot be null.
the license. So for Adobe, we are not
Okay.
going to upgrade it. They are planning to.
So ESSN can hold any value from SSN value that is already there.
Right now, since Adobe is there, so
Okay,
write
but
that only
if
that
there are
we
say
are testing. Don't
10
write
employees,
specific
the
name,
SSN values
but
are 1 to 10.
write that as
Okay.
per OSC
In
regulations,
ESSN, we have to
working
put the
on
value
getting the Adobe
from 1 to 10. Any value from 1 to 10.
but it
We
is
cannot
still
put value
existing
0,
in the
we cannot put value
Apart
11.
from this Java deployment, there
That
are
will
few
violate the
deployment
concept.
is pending, in which I am working on it,
Okay.
and which are in the testing.
So any doubt regarding primary key and foreign key?
Yeah, you can update them also
Alright, sure.
in case.
Any doubt regarding primary key, foreign key? Because based on this, I have to discuss the whole chapter.
Okay.
If you don't have that concept
Anything
here, then
from security
I think
side?
So please repeat again.
which portion?
The foreign key portion.
Primary key is clear to everybody?
Yes, sir.
Any doubt regarding primary key?
No, sir. No doubts in primary key.
No, sir. Again, I am repeating, any doubt regarding primary key? Okay, so I think there is no doubt regarding primary key. So I am explaining the foreign key only. Okay, now see this example. Just first see this example. Here, what I have told in case of foreign key in primary key involve only one attribute or one relation. Okay, what I have told regarding primary key involves only one relation. So suppose if you take employee relation or employee table, then SSN is the primary key. Okay, fine. Now in case of foreign key, what I have told, foreign key involves more than one relation. Okay, so we have to take two relations. So employee and second one is works on. Okay. Now what I have told, one is referencing relation, another is record relation. Okay, so in this case, among this employee and works on, which one is the record one and which one is the referencing one? Which one is the referencing one?
Sir, employee.
No. Works on is the referencing one because from ESSN, this ESSN will refer the SSN of employee. ESSN is the foreign key of works on, and SSN is the primary key of employee. And what I have told, one or two attributes of the referencing relation will refer the primary key of another relation. So SSN is the primary key of employee, and that is referred by ESSN of another table, works on. Is it clear? So which one is referencing and which one is referred?
So how do you understand that which relation refers to another relation, and I mean, what is the referred relation and which one is the referencing relation? How do you understand that?
No, you don't have to understand, because the database designer have to understand. If you are the database designer, then you have to create these foreign keys based on some requirement. Okay, and how to do that, I will come to later. Is how you will understand why we have to create foreign key. That I will come later. Or when we have to create foreign key, which one will be the referred one and which one will be the referencing one. That I will discuss. How to decide that too.
Okay, sir.
Okay, now is it clear that which one is referencing and which one is referred?
Yes, sir.
So primary key is referred, and here the foreign key is referencing. Okay, so employee relation is referred, works on is referencing. Clear? Okay, then if you do that, after that, in ESSN, that is in works on, if you put the data, if you put the values in the works on, lot of tuples you can put, then this tuples value for ESSN can be any value of SSN that is already there in this relation. It cannot be any other value. Suppose in this table, employee table, you are having say 10 employees. Okay. Now for 10 employees, you must have unique SSN value. So the SSN value of those 10 employees are 1 to 10. Okay, assume that. Okay, 1, 2, 3, 4, 10. Now in the ESSN, you cannot put any value apart from 1 to 10. You have to put any value from 1 to 10. You have to choose any value from 1 to 10. Clear? That is one constraint that you are putting by means of referential, that is known as referential integrity constraint. Clear? Clear to everybody?
Sir, I have a question. That is, if there are two tables and they are in the referencing relation, and can both the table have same attribute as per primary key?
No. In this table, employee table, SSN is the primary key. Okay. Now in the works on table, ESSN and P number together is the primary key.
Okay, sir.
Not same. Here ESSN is the part of primary key. Here SSN totally is the primary key. Here ESSN and P number together is the primary key. Here SSN alone is primary. Here?
Yes, sir.
So any doubt regarding this referential integrity constants and foreign key? Any doubt? Okay. So after defining this table, what you can do, you can enter values into this table. These are values. You can enter into this table, and now your company database looks like this at a particular moment. These are couples. Okay. Now, what I have told earlier, that now you have to know that how you will convert this ER model into relational model. What are the steps? How you can do that? Okay. How you can do that? Okay. Now, see, in when we learn Dbms, our teacher don't tell that how to do that. Okay, they have not discussed this thing. Okay, they have not discussed all the rules. Okay. But if you cannot know, if you don't know the rule, how to convert, or if you don't know the strategy, how to convert ER diagram into relational model, so you will face a lot of difficulty. Okay. So you have to know the rules. How you can do that? Then only you can do it correctly. Otherwise, you have to do a lot of trial and error. Okay. So I will show the steps. First thing, ER to relational mapping algorithm means how you can convert ER model into relational model. Okay. So first step one is mapping of regular entity types. First we will convert regular entity into relation or table. So in this diagram, what are regular entity? Regular entity type.
So employee, department, project, or dependent.
No, dependent is not regular entity. Dependent is
Okay, we can pick it. We can take it.
So there are three regular entity. One is employee, another is department, another is project. So what we have to do, first we have to convert these three into relations. Means for these three entity types, we have to create three relations or three tables. That is the first step. Fine. So second step is mapping the weak entity type. Okay, so weak entity, in this we are having only one weak entity, so we have to create a table for weak entity, that is dependent. Yeah? So how many relations we have created so far? Four relations. Three regular entity and one for weak entity. Then mapping of binary one-to-one relation type. So see, there are one-to-one relation, one-to-one relation. There may be one-to-many relation. There may be many-to-many relation. Okay. So the next step is, first we have to map one-to-one relationship type. Second thing, we have to map one-to-n relationship type. First step is, we have to map binary n-to-n relationship type, means many-to-many relationship type. Okay, we have to do this. First one-to-one, then one-to-many, then many-to-many. Clear? Next, some attributes may be multi-valued. What I have told, I have given one example here, multi-valued attribute. Which one? In this ER diagram, which one may have multi-valued attribute?
The location.
Locations of department that may be multi-valued. Okay, so next step is to map multi-valued attributes. Number 7 step is mapping of n array relationship type. Here we have done all for binary. Last one is n array. Okay, so if any ER diagram we are having n array means ternary relationship or more than that, then we have to map that relationship type. Okay, so these are the steps. Then after that, what I have told, in ER model we cannot show specialization, generalization, we cannot show category and all these things. So then we have to concentrate on extended ER model, and number 8 step is option for mapping specialization and generalization. So after that we have to concentrate on specialization and generalization, and we have to convert that type of ER diagram into relational model. Okay, number 8 step. And last one is mapping of union type, that is categories. Okay, and we have to convert it into relational model. So these are the steps you have to follow in order to convert a ER model or extended ER model into relational model. Okay, now I will explain all these steps one by one with example. Okay, so first one, step 1, mapping of, okay, any question regarding up to this, step number 9? Okay, so first step number 1. Step number 1 was mapping of regular entity types. Okay, so for each regular or strong entity type, E in the ER schema create a relation R that includes all the simple attributes of E. Okay, now choose one of the key attributes of E as primary key of R. If the chosen key of E is composite, the set of simple attributes that form it will together form the primary key of R. Okay, so what we are doing? So for each regular entity type, that is employee, department and project, we are creating one relation. So here we have to create 3 relations, and in those relations we are putting the attributes of this into the relation. Okay, so employee having how many attributes? 1, 2, 3, 4, 5, 6, and the name can be divided into 3. Okay, so 6, 7, 8. So total 8 attributes are there. So we have to create employee relation by means of these 8 attributes, and then among these we have to choose one attribute as primary key, 1 or 2 attributes as a primary, or 3 attributes as a primary key, so that it can become unique. Okay, so just see what we have done. So see how many attributes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so department number is there. Okay, I will explain this thing because this is the foreign key, and supersession is also the foreign key. So forget these two. See, all 8 attributes are there up to 7. Okay, so first we have to create up to this for employee. Here, Similarly for department. Department, how many attributes are there? Name, number, locations. Okay. So name, number, locations will be there because location is the multi-valued attribute. So for multi-valued attribute, we have to deal it separately. Okay, so that I have told at the end we have to deal with multi-valued attribute. So initially we are creating department table by means of dname and dnumber. Okay, then we are having project. So name, number, location. Project, name, number, location. And in the department table, D number is chosen as a primary key. In the project, P number is chosen as a primary key. And in the employee SSN is chosen as a primary key. So at the first step, we will do all this. Clear? First step is clear to everybody. Just read this.
Yes, sir.
Just read this. Read this. And at the end, example is written. Clear to everybody? Any doubt? Any doubt?
No, sir.
Okay. So, yes?
So no doubt, sir. Clear.
Okay. So I am going to the second step, means weak entity type. So for each weak entity type W in the ER schema, here weak entity is dependent. So W is dependent. Okay. With owner entity type E, create a relation R and includes all simple attribute or simple components of composite attribute of W as attribute of R. Okay, so dependent is the weak entity. So which is the owner of dependent? Which entity is the owner of dependent?
Employee.
Employee, fine. So owner entity type is E means employee. Okay, so what we have to do? We have to take all simple attributes of W except multi-valued attributes, and we have to form a table. Okay. See. Dependent. How many attributes are there? 1, 2, 3, 4. So 1, 2, 3, 4. Apart from that, we are having ESSN. That is the foreign key of this dependent, and this is the primary key of the owner entity. That is SSN. Okay, that we have done. So we have taken all attribute of the dependent entity. Apart from that, we have taken the primary key of the employee. Okay, and that is in the form of foreign key. So the ESSN is the foreign key which is referencing SSN of the employee, that is the primary key. Okay, and ESSN is the record relation, referencing relation, and SSN or employee is the record relation. Okay, now in addition, include as foreign key attribute of R the primary key attributes of the relation that corresponding to the owner entity types that I have told. SSN. The primary key of R is the combination of primary keys of the owner and partial key each entity type W, if any. So see, in the dependent relation, the primary key is the combination of ESSN, that is the SSN, and the dependent name. Okay. So see here. The ESSN and dependent name together is the primary key of the each entity type. That we have to do. Okay, so name and primary key of the owner together will form the primary key of each entity type. Clear? Clear? Now read this. Read the example. Create the relation dependent in this step to correspond to the weak entity type dependent. Include the primary key SSN of the employee relation as the foreign key attribute of dependent. Rename to ESSN. The primary key of the dependent relation is the combinations of ESSN dependent name because the dependent name is the partial key of dependent. Clear to everybody?
Yes, sir.
Yes, sir.
Okay. Now third step. Mapping of binary one-to-one relationship type. Okay, so far we have worked with entity type. Now we will start working with the relationship type. Okay. Now first we will start with one-to-one relation. For each binary one-to-one relationship type R in your schema, identify the relation S and T that correspond to the entity type participating in R. So in a binary one-to-one relation, we have to first identify the entity which are participating in that relation. Okay, there are three possible approaches. One, foreign key approach. Okay, so three approaches are there. Okay, you can choose any one of these approach. Okay, based on some conditions are there. Based on some conditions, these three approaches are there. Among these three approaches, you can choose one based on some conditions. Okay. Now, foreign key approach, choose one of the relation S and say and include a foreign key in S, the primary key of P. It is better to choose an entity type with total participation in R in the role of S. Okay, so one-to-one relation manages is mapped by choosing a participating entity type department to serve in the role of S because the participation in the manager's relationship type is total. Okay, so what is this training? First, just go to the example. Managers. See this lesson. Okay. One side is total participation. Another side is partial participation. Okay. So what we have to do? In the department relation, okay, we have to add the primary key of another relation that is participating in that relationship. So in the manager's relationship, dependent a department and employee is participating. Among these, department participation is total. So we are taking the department table or department relation, and in that relation, we are adding the primary key of employee. Okay. So see here, in the department, we have added these two at the beginning. Now we have added the primary key as manager SSN, and this manager SSN is referencing this SSN. So this is the foreign key over here in this table. Okay, this approach we can follow in order to implement this managers relationship. Clear? This approach is clear? Clear to everybody? Okay. Now, second approach is merge relation option. An alternative mapping of one-to-one relationship type possible by merging the two entity types and the relationship into a single relation. This may be appropriate when both participations are total. So what you can do in this approach, if in a one-to-one relationship, if both participation is total. Okay, suppose see, this side is also total and it is one-to-one. Okay, but this side is not total, so we cannot apply this theory over here. Okay, so in that case, what we can do, we can merge this employee table and this department table, or employee relation and department relation together, and we can form a single relation. This approach, second approach, but in this case we cannot apply this because this approach, this participation is not total. Okay, so that is the second approach. Third approach, cross-referencing reference or relation approach. The third alternative is to set up a third relation R for the purpose of cross-referencing the primary key of two relations S and T representing the entity type. Okay. So what is this telling? Third approach is create another table or relation, okay, for managers. That table name will be managers. Okay, and in that table there will be three fields. One will be the SSN number, second will be the department number, that is the primary key. First SSN is the primary key of employee, second is the primary key of department, that is the participating entity, and third is the start date, that is the attribute of this relation, that is the third approach. And then from this table, the SSN is referencing this, and the department number is referencing this. So SSN is the foreign key for this, department number is the foreign key for department, by which you can express managers, and the start date will hold the value of this relation. Okay, so these three approaches are there. Okay.
Sir,
Yes.
সেকেন্ড অ্যাপ্রোচের ক্ষেত্রে এমপ্লয়ি আর প্রজেক্ট অ্যাপ্রোপ্রিয়েট হবে না?
Employee and project.
হ্যাঁ,
But it is not one to one, it is many to many.
আচ্ছা
I am talking about one-to-one only.
আচ্ছা 1 to 1 হতে হবে দুদিকেই টোটাল হতে হবে পার্টিসিপেশন
না সেটা খালি সেকেন্ডটার জন্য এটা খালি সেকেন্ডের জন্য সেকেন্ড অ্যাপ্রোচের জন্য if we want to merge two relation in that case both participation are total but other cases such conditions are not there here only one side may be total and in case of third one no conditions are there. In case of first approach, one side must be total. In case of second approach, both sides must be total. In case of third approach, no such conditions. Clear?
yes sir
Now these approaches are clear to everybody. Third one is step number 3. Then under step number 3, there are 3 approaches. I have designed various databases when I was in industry. So I followed this approach, hard approach, and industry people follow this approach, hard approach, because it's a general one, no such conditions. Yeah. Clear to everybody? Yes or no?
Yes. Yes, sir. Clear.
Yes. Okay. So next, step number 4, mapping of binary or 1 to n relationship type. Binary 1 to n means 1 to n. Okay. Now, for each regular binary 1 to n relationship type R, identify the relation S that represents the participating entity type at the n side, many side. Okay, so among two entity, which one is participating at the many side, we have to identify that. Now, include as foreign key in S the primary key of relation P that represents the other entity type participating in R. So what we have to do, we have to add the primary key of other relation, means that is at the one side. Okay, so many to one. So at the main side, we have to identify the relationship. Okay, or table. In that table, we have to add the primary key of the table that is at the one side. Okay, then include any simple attributes of the 1 to n relationship type as attribute of S. Then if any attributes are there in the relation itself, okay, include those attributes into S. That is main side. Okay, now in this diagram, there are various 1 to n relationship type. Works for control, supervision in the figure. Okay. Now, for works for, we include the primary key D number of the deployment relation as the foreign key in the employee relationship and call it DNO. Okay, so let's see. Let's see the example. Works for. Works for 1 to n, 1 to n. Many side employee. Okay. Now go to the employee relation. So in the employee relation, so far what we have done? So far we have created 8. Initially we have taken 8. 1, 2, 3, 4, 5, 6, 7, 8 up to salary. Okay. Now in this table we have added the foreign key of the relation which are at the one side of many-to-one relationship. So one side many-to-one relationship, there is department, and department number is the primary key. So take this primary key and add it to the employee. Okay, employee relation. So what we have done? We have added DNO, that is the primary key of the department, to the employee as foreign key. Okay, and this DNO is referencing this D number. So this is referencing, and employee is referencing, and department is referred. Okay. Here, similarly, if you take this employee and again 1 to n, supervision supervised by Z, both side employee. So if you see this relation, left hand side employee, right hand side employee. So what you have to do, you have to add the primary key as a foreign key. So primary key of employee table is SSN, and that you have to add into the employee table as foreign key. Okay. So this super SSN is the foreign key that is referencing this SSN. Okay. So we have added this one to express this relationship. Clear?
No, sir. Can you repeat this step again?
Second one, only this one or this one. Sorry, box one.
So from what song?
Or box one. See what I have told. In order to express this relation, first in one to many relation, you have to identify the table which is at the many side. So which is at the many side? Which one at the many side? Employee. So take employee table, employee relation, and in this relation add primary key of relation which is at the one side. So department is at the one side, and primary key of department is D number, that we have to add this employee table. See, that we have done. Yes?
Yes, sir.
Now read this. Read this. What I have told and what is written over here. Clear?
Yes, sir.
Okay. Now, another thing that I forgot to mention. Now, in one to many relationship type, there may be some attribute for work spot. Means here there may be some attribute like this, start date. there may be some attribute for works for. Those attributes you have to add it into this table, many size table. Okay. As there are no attributes here and here, so no question of adding any attribute, not having question of adding any attribute. Okay. So next comes many to many. Many to many. How to map this? Okay. So binary many to many attributes. For each regular binary many to many relationship type R, create a new relation S to represent R. So we have to create a new relation or we have to create a new table. Include as foreign key attribute in S the primary key of the relation that represent the participating entity types. Their combination will form the primary key of S. So in the new relationship, the primary key of the participating entity type will form the primary key of the new relation. Okay. Also include any simple attributes of many-to-many relationship type or simple components of composite attribute as attribute of S. Okay. So see what I have told. Just go to the diagram. Walks on. It's a many-to-many. What I have told that for walks on, we have to create a new relation. Means we have to create a new table. Okay. So see, walks on, a new table. Now, what will be the attributes in that table? What I have told that you have to take the primary key of participating entity type in that relationship. Participating entity type in this relationship. So here, which entities are participating in this relationship? Employee and project. Employee and project. So what you have to do? You have to take the primary key of employee and primary key of project. So primary key of employee is
SSL
and project
P number.
So see, we have done that ESSN and P number. Okay, and these two together will form the primary key of the relation. Primary key of works on. These two together. Composite primary key. Okay. And this ESSN is the foreign key for employee. So this ESSN, there will be an arrow that will point to this SSN, and this ENO will point to this P number. Okay. And last point was that any simple attribute in that relation will be added into this table. So see, any simple attribute that is hours will be added into this relation. So we have added hours. So this is the way we can convert or we can map a end-to-end relationship type or many-to-many relationship type. First we have started with one-to-one, then one-to-many, then many-to-many. Here, binary. We are talking about binary relationship type. Clear to everyone? Yes or no?
So clear, somewhat cleared.
So clear.
Okay.
Okay, yes, sir.
Now,
So actually, it would be very much, helpful if we could do this in the practical. Then we
yes,
would understand it.
yes, yes. I will make that animal. Okay. So next step is step number 6, mapping of multi-value attribute. Okay. So just go there, mapping of multi-value attributes. So for each multi-value attribute, create a new relation R. The relation R will include an attribute corresponding to A, that is the multi-value attribute, plus the primary key attribute K as the foreign key in R of the relation that represent the entity type of relationship type that has A as an attribute. Okay. The primary key of R is the combination of A and K. If the multi-value attribute is composite, it includes all simple components. Okay, just go to this figure again. So in this diagram, there is only one multi-value attribute. What is that? There is only one multi-value attribute. Which one? That I have told earlier.
Location.
Deployment location is only one multi-value attribute. Okay. So for any multi-value attribute, what I have told, we have to create a new relation, means a new table. Okay. So we have created a new table. Deployment locations. Okay. In this table, one attribute will be the multi-value attribute itself, D location. Okay, and another attribute will be the primary key in which this D location is belongs. Primary key of the entity in which D location belongs. Clear? So see, D location belongs to dependent. Okay, and which one is the primary key? D number is the primary key. So we have to add that attribute here in the new relation. So in case of multi-value attribute, we have to create a new relation. In the new relation, multi-value attribute will be there, and the primary key of the entity in which D location belongs, that will be there as foreign key. So see, this D number will refer this D number. There will be error.
So both will be of with the same name, D number.
No problem.
Okay.
Because these are in two different tables. No problem.
So could we have used ESS? I mean, in employee table and in another table, yes, works on table. In employee table there is SSN number, and works on table there is ESSN number. Could we have replaced the ESSN with SSN?
Yes,
The attribute
no
name.
problem. Yes.
Okay.
Because these two in two separate tables. No problem. But in this table, if you put another SSN, that will create problem. Clear?
Yes, sir.
If it is in two different tables, then there is no problem. Okay, so now it is clear how to deal with multi-value attributes. Okay, now see what is written over here. What I have told and what is written over here. Okay. See, mapping of multi-value attributes. What I have told and what is written over here. Read this. If any doubt, you can ask. Clear? Now, in this ER diagram, whatever is there, we have dealt with that. Okay. Whatever is there. Okay. Because the last one is to deal with n array relationship. Here, no question of n array relationship, all are binary. So this conversion is over. Okay. So if you apply this thing, so after that you will get this. You will get this diagram. What I have told, and probably you are getting the answer that how we can understand that what will be the foreign key and what will be the primary key. How we can decide what will be the foreign key and what will be the primary key. Is it clear to everybody? Any doubt regarding this diagram?
So can you explain that super SSN number in employee? Why did we create that?
In the diagram,
couldn't we have used SSN?
What I have told that in case of the same table, we cannot repeat the name. So here we cannot write SSN. We have to give a different name. But if it is in different table, then we can use SSN.
But in table employee, both super SSN and SSN have the same values, right?
Yes.
So why did we create another column named super SSN? Couldn't we have used SSN?
No. See, suppose this is the suppose you are entering a employee record. Okay. That employee must have a SSN number. Okay. And that employee must have his manager SSN number, who is the supervisor of that employee. So you will put the SSN number of the employee here and SSN number of his manager, you will put it here. Yeah?
Yes, sir.
So super SSN is a foreign key or primary? Foreign key?
Super SSN is the foreign key because it is referencing a primary.
Yes.
And see, a employee's manager is also an employee. Okay.
Yes.
So this super SSN is referencing that employee, means manager.
Yes.
The manager data will be here in the same table. So by means of the super SSN, you will get the manager data.
Yes, sir. Yes, sir.
Clear?
Yes, sir.
Okay. Now, next come this type of thing, that is n array relationship. It's not binary. See, this relationship, 3 entities are participating. So it is n array or ternary relationship. Okay. Supplier is supplying some goods for some project and then some part. Okay. So for say for a project, different items are required. Those items are supplied by more than one supplier. Okay, one supplier may supply same parts, means more than one supplier may supply same part, or a supplier can supply for many projects. Many parts can be supplied into many projects. Many parts can be supplied by many suppliers. So these three are related with each other. Now, in case of supplier, supplier name is the primary key, or supplier number is the primary key. Part number is the primary key. Project name or project number is the primary key. Okay, and in the supply, which supplier is supplying which part for which project, that quantity. Quantity is an attribute of this relationship. Okay. Now, if this is the case, how to convert this ER diagram into relational diagram? Relational model. ER model into relational model. Okay. So, what is written over here? For each n array relationship type R, where n greater than 2, create a new relationship S to represent R. Okay. Include as foreign key attributes in S the primary keys of the relation that represent the participating entity types. Also include any simple attribute of the n array relationship type or simple components of composite attribute as attributes of S. Okay.
So your voice is breaking.
So
It's unclear.
So there is distortion in
just
the
read
voice.
this. Just read this. Just read this. Read this. Read this one. Read this one. Okay, done? Have you read this?
Yes, sir.
Yes, sir.
Okay. Now, what we have done, we have created this relation for representing the ternary relation. We have created a new relation. In that relation, we have taken the primary key of each entity type. See, three entities are participating, three entity types are participating. From each entity type, we have taken the primary key. Okay, and these three together will constitute the primary key of this relation. And after that, we are adding the simple attribute of that relation itself. So, simple attribute of this relationship is quantity. So, we have added the quantity over here. This is how we can convert a ternary relationship into relational model. Is it clear to everybody? And this S name, foreign key over here, and primary key, P, project name, part number. These three are foreign keys, and these are primary keys of these two. Clear? Clear to all?
Yes, sir. Yes, sir.
Okay. So summary of mapping construct and constraint. In the ER model, what are the names, and in the relational model, what are the names? Okay, later I will give the slide, just read this. Okay. So next come EER model, extended ER model. If we got a ER model, extended ER model, how to convert that extended ER model into relational model? Okay, so in the extended ER model, there is specialization generalization that is not there in ER model. Okay, so if there is any external specialization generalization, means there is some superclass and there is a superclass and there are some subclasses, then what to do? Okay, so convert each specialization with n subclasses S1 to Sn and generalize superclass C, where the attributes of C are K 1 to n and K is the primary key, into relational schema. Use one of the four following options. Okay, so what we are saying here, C is the superclass and S1 to Sn is the n subclasses, and A is the primary key of the superclass and A1 to An are the attributes. Okay, now if this is the case, then you have following four options. Okay, number A option, multiple relation superclass subclasses. Create a relation L for C. So you have to create a relation for superclass with attributes A, A1 up to An with primary key K. Create a relation Li for each subclasses Si, where I is varying from 1 to m. Means for each subclasses you have to create a relation. If there are n number of subclasses, you have to create n relation with the attributes Li, K, union attribute of Si and primary key as K. This option works for any specialization, total, partial, disjoint, overlapping. Okay. So if there are, say, one superclass, you have to create a relation for that. If there are three subclasses, you have to create three relations for each subclass. Means one relation for each subclass means total you have to create four relations. Okay, in the superclass relation, the attributes will be primary key and the other attributes of superclasses. For the subclasses, you have to take the primary key of the superclass plus the attribute of individual subclasses. Okay, and this strategy holds for any type of specialization. Maybe it's partial, disjoint, overlapping. What is partial, disjoint, overlapping, that I have discussed earlier. Okay, so see here, employee is there, superclass, and three subclasses are there. Okay, so how many relations you have to create? How many relations we have to create? No answer. It may be a wrong answer. What is the problem? I am not going to give any marks.
The correlation.
Fine. So, one relation for employee and one each for every subclass. So, one for secretary, another for technician, another for engineer. Now, in those relations, what attribute we will put? In the superclass, we will put the primary key of the superclass and other attribute of the superclass. See, primary key, other attributes, name, 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 birth date, address, job type. Okay, so how many attributes? 1, 2, 3, 4, 5, 6, 7, 7 attributes. So see here, 1, 2, 3, 4, 5, 6, 7, 7 attributes. Okay, now for every subclasses, we have to take the primary key of the superclass, SSN of the superclass, and we have to add the attribute of the subclasses. So attribute for secretary is typing speed. So we have added that. We have taken the primary key of the superclass into the subclass. Now we have added the SL attribute of that subclass. So here, now with this, read this again. 8A. Clear, first one? Clear? Okay, second option, create a relation Li for each subclasses with the attribute of Si union K1 to A1 to An and primary key of Ni is K. This option only works for specialization whose subclasses are total. Every entity of the superclass must belong to at least one of the subclasses. Okay. So in this case, what I am telling, or we are telling, see, we don't have to create any class for the superclass. So sorry, we don't have to create any relation for the superclass. For every subclass, we will create a relation. Okay, create a relation in that the attribute of the subclass will be there plus all attributes of the superclass including the primary key will be there, and the primary key of the superclass will be the primary key of this relation for each subclass. Okay, but this strategy will work if the participation is total, otherwise it will not work. Okay, those subclasses are total. Okay, so in this case, how many classes, how many relations we have to prepare? We have to do No answer. How many relation? We don't have to make any class, any relation for superclass. For each subclass, we have to create one relation. So in that case, how many relations we have to prepare?
The two relation.
No, three.
Three.
We don't have to create any relation for the superclass. For each subclass, we have to create one relation. So three subclasses are there. For three relations, we have to prepare. Okay.
টোটাল যদি হয় তাহলে চারটে রিলেশন হবে।
If the participation is not total, then this approach is wrong. Means this approach is not applicable.
আচ্ছা।
If the participation is not total, then we cannot apply 8B. Option 8B is not applicable. তখন 8A অ্যাপ্লাই করতে হবে, 8B হবে না।
আচ্ছা।
এটা বলছি।
আচ্ছা আচ্ছা আচ্ছা।
ঠিক আছে?
হুম।
So if there are three subclasses, we have to give three relation. So one relation for secretary, second relation for technician, third relation for engineer. Now, in those relations, how many attributes will be there? In the secretary, all attributes of employee will be there. Means 1, 2, 3, 4, 5, 6, 7. 7 attributes plus the attribute of secretary will be there. That is the typing speed. So total 8 attributes and SSN will be the primary key. So for secretary we will have that relation. Similarly for technician, SSN and other thing will be there. SSN will be the primary key and the new attribute will be key grade. For the engineer, all will be there. SSN will be primary key and N type will be the last attribute. So sorry, engineering type will be the last attribute. So 3 times 3 years. Okay. So that is 8B, option 8B. Okay. See this diagram. Participation is total. So what you can do is we cannot apply this thing here 8B because the participation is not total. But in this case, participation is total. So for that reason, what we can do, we can create two tables. One for car, another is for truck. For the car, these 3 will be there and these 2 will be there. Okay. See. Okay, and for truck, these 3 will be there and these 2 will be there. See. Okay. There is a typing error, the stomach is not there. So, try this. Okay. I think option 8B is clear to everybody. Then, third option 8C. Single relation with one type attribute. Okay. In this case, we will create only one relation. create a single relation L with attribute K 1 to n plus attribute of S1 union attribute of S2 union attribute of Sm, means take all attribute from all subclasses plus one type attribute, and primary key will be the primary key of the superclass. The attribute key is called the type attribute or discriminating attribute that indicates the subclass to which the tuple belongs. Okay. So in this case, we will create a single relation. See, we will create a single relation. And what will be that relation? In that relation, we will put all attributes of the superclass. Okay, all these attributes of the superclass means 1, 2, 3, 4, 5, 6, 7. 7 attributes of the superclass. So see, 1, 2, 3, 4, 5, 6, 7. Okay, so all attributes of the superclass. Okay, then we will put all attributes from all subclasses. So we will take typing speed, E grade, engineering time from all subclasses. Plus, there will be a type attribute. Okay, so 7 attributes, then 3 attributes, means 10 attributes, and last attribute will be the type attribute, which will specify which type of employee that person is. Okay, so see here, job type. Okay, it is not complete, there will be many other. Okay, so according to this ER diagram, there will be 7 from here, 3 from here, and another one is job type, that is here. Okay, so altogether 11 attributes will be there. Okay, clear to everybody?
যেগুলোতে কোনো ভ্যালু থাকবে না সেগুলো তাহলে কি নাল হয়ে যাবে?
যেগুলোতে কোনো ভ্যালু থাকবে না সেটা নাল হবে।
আচ্ছা।
If you put data of secretary, in that case you cannot put the value of T grade, so that will be null. And you cannot put the value of engineering type, so engineer type, so that value will be null. Okay. And job type will be the secretary. Value of job type will be secretary. For secretary. For technician, value of job type will be technician. For engineer, the value of job type will be engineer. Okay. So I think it is clear. 8C, option 8C. Then last option, that is 8D, single relation with multiple type attributes. Okay, single relation as before, but here we are having only one type attribute. Here we are having multiple type attributes. Only difference is this. Okay, so in the attribute list, all attributes from the superclass from means then plus attributes of subclasses, then multiple type attributes. Means if there are 3 subclasses, there will be 3 type attributes, T1 to Tm, and primary key will be the primary key of the superclass. Okay, and this type attribute will be Boolean type. Boolean type means true or false, yes or no. Yeah. So if you convert this one according to the 4th strategy, so there will be 7 attributes from here, 3 attributes from here, then 3 type attributes, means 1, 2, 3, and last 3 type attributes will be Boolean type. Okay, means first attribute will ask whether that person is a secretary or not. If it is a secretary, then yes, otherwise no. Second attribute, technician or not, yes, no. Third attribute, engineer or not, yes, no. That type of thing. that type of relation will be there. Okay, so altogether in that relation there will be 7 plus 3 means 13 attributes will be there. Is it clear to everybody? Okay. Now, mapping of shared subclasses, multiple inheritance. Just see this one. See what I have told. The student assistant having more than one superclass. Student assistant has the property of employee as well as student. So how to map this thing into the corresponding relational model? Okay. So a shared subclass such as student assistant is a subclass of several classes indicating multiple inheritance. These classes must all have the same key attribute, otherwise the shared subclasses could be modeled as a category. We can apply any of these options discussed at step 8 to be a shared subclasses subject to the restriction discussed in step 8 of the mapping algorithm. Below, both 8C and 8B are used for the shared classes student assistants. So whatever we have discussed in 8, that we can apply over here. Okay, and see, in this example, we have applied 8C and 8B. Option number 8C and 8B. And see, we are getting this person class, employee class, alumnus, student, alumnus degree, then student. Okay, so then we can use that. Okay, see. Okay. We are using this type attribute, RA flag, PA flag, obviously. Then mapping of union types, categories. Okay. So what I have told in extended ER diagram, we have shown another thing, that is union. Okay. I have given an example that suppose the owner of the car may be a person, may be a bank, may be a company, and here we have to do the union in order to decide about the owner. Okay. Then a registered vehicle may be a car, may be a truck. Again union. Okay. So for mapping a category whose defining superclass have different keys, it is customary to specify a new key attribute called a surrogate key. So in this case, what we have to do in this case, we have to create a new attribute known as surrogate key. Okay, known as the surrogate key, and that will do the work. In this example below, we can create a relation owner to corresponding to the owner category and include any attribute to the category in this relation. The primary key of the owner relation is the surrogate key, which is called owner ID. Okay, so see here, these three together will form the union, and that union, after that union, we are getting a new relation, that is owner, and in the owner we are having owner ID, and owner ID is the surrogate key. Similarly here, these are registered vehicle is the entity which is participating in this relationship, and the license plate number is the surrogate key. Okay. So what we have to do? See, parcel.
Set to boost now.
Okay, just see the example. Parcel. See, here parcel. For parcel, we are creating one relation. SSN is the primary key. For bank, we are creating a relation. With bank name is the primary key. Company name is the primary key. Then we are creating a relation owner ID, and owner with owner ID is the primary key as well as surrogate key. Okay. Now registered vehicle ID, license plate number. Okay. So this is the surrogate key. I think vehicle ID is the surrogate key, and car we are having vehicle ID. For truck we are having vehicle ID. Okay. So first just go to the figure. First for parcel we are creating a relation. Okay. So SSN is the primary key. Bank we are creating a relation. Bank name is the primary key. Company we are creating a relation. C name is the primary key. So these three relations we are creating. Okay. So no problem regarding these three. Any problem regarding these three?
No, sir.
Okay. Now, so go here. For these two, for car, we are creating a relation with vehicle ID as the primary key. For truck, we are creating a relationship with vehicle ID as a primary key. So car and truck, these two relations. Any problem regarding these two?
No, sir.
Okay. Now, we have created a owner relationship with owner ID. Okay. So, owner ID is the surrogate key. Owner ID is the surrogate key. Okay. And owner ID may be any ID from these three. Owner ID may hold any value from these three values: SSN, B name, and C name. Owner ID may be any of these three. Yes. In these three tables, there may be some value. Okay, some SSN value, some bank name, some company name. Now, owner ID may be any values from these three: SSN, B name, C name. It can be a B name, it can be a C name, it can be a SSN. Owner ID. Yeah. Okay. Now, registered vehicle. Registered vehicle having two attributes: vehicle ID and license plate number. Forget about license plate number. This vehicle ID can hold any value from this car vehicle ID or truck vehicle ID. So, this vehicle ID can be truck vehicle ID, can be car vehicle ID. Is it clear? Any doubt? Okay, so no doubt. So now, if all these are ready, then what we can do, we can express this relation. What is that? In that relation, what we can put? We can put this owner ID and this vehicle ID and these two together will constitute the primary key. And this owner ID will refer to this. This is the foreign key over here, and this vehicle ID will refer to this, the registered vehicle. And this purchase days and name or regular that we will get from here. These two. Okay, so after that we get this. Okay, and this is the equivalent relational model corresponding to this in a type. And this is how we can convert a ER model into relational model. Okay, so I have shown another ER diagram for this bank. Okay, and corresponding relational model may look like this. This is another way of defining relational model. Okay, and see these dark attributes are primary key of this table. This is the table name, relation name, and these are the attributes. And this is the primary key. And see branch name is the foreign key over here that is referencing the branch name of the branch. So this is a branch schema diagram. Okay, so after generating this schema, you can enter value into this table. So this may be the value. You can enter into the table. Okay. Then in the loan relation, you can put this value. Then in the borrower relation, you can put this value. Okay, so in this way you can put values, and then after putting values, your database is ready. Then you have to then you can do your SQL, you can run your SQL. So first thing is that you have to start with the problem statement. From problem statement you have to build the ER model. Then from the ER model you have to build the relational model. Then when your relational model is ready, then using the data definition language DBM, you have to define the relation or define the table. Then after definition is over, by means of data manipulation language DML, you have to enter data into those tables. Okay. Then after your data entry is complete, then you can run different types of queries on those tables. Okay. This is how this database system design offers. Everyone do database design. So, if you don't know that what is ER diagram and what is relation, from the problem statement you cannot directly do SQL. Means you cannot directly run SQL. Okay, you have to do it step by step. Okay. So, what I will do, I will give some assignments. Okay. One thing is that I have already told that in your book, lot of problem statements are given. From that problem statement, you have to first build the ER diagram, and then from the ER diagram, you have to draw, you have to create the relational diagram. Okay, so I will give some problem statement, and from that you have to do these two. Means you don't have to do anything on a computer, you have to just do it on pen and paper. Okay, but do it yourself. Okay, do it yourself. You have to, I will give the problem statement. Okay, and you have to do it in pen and paper, and then scan it and send it to a mail ID. I will give the mail ID. Okay, I will give the problem statement. Okay. For your practice on.
Sir, PDF format is changed करते हैं.
हाँ?
अच्छा.
वो तो मुझको चाहिए.
Sir, PDF format is changed करते हैं. Sir, PDF format is changed करते हैं.
PDF?
Hello. পিডিএফ ফরম্যাটে স্ক্যান করে পিডিএফ ফরম্যাটে সেন্ড করব তো?
হ্যাঁ, পিডিএফ এ সেন্ড করো, পিডিএফ। হ্যাঁ,
ঠিক আছে স্যার।
now this is the end of this chapter. So basically what in your syllabus you will get only the 2 words, okay, that is relational model, okay, and on these 2 words I have taken this class, this class maybe of yesterday's class and last class and this class having 67 slides, okay, a total chapter on 2 words, relational model. Okay, and this is a very important chapter because if you cannot do this, means if you cannot convert your model into relational model properly, then your total database design will be wrong. And you have to scrap the whole database after say 1 month of work. If your design, basic design is wrong, so you have to do it correctly, or you have to know it correctly. If you don't know that, then you will never be able to work on database project.
স্যার এই স্লাইডটা কি গ্রুপে দিয়ে দেবেন?
আজকে দিয়ে দেবো।
আচ্ছা, থ্যাংক ইউ।
ক্লাসের পরে দিয়ে দেবো। এবং আরেকটা জিনিস যেটা আমি বলছি, কারণ আজকে অনেকগুলো স্টেপস আমি পড়ালাম এবং অনেকগুলো এক্সাম্পল দেখিয়ে দিলাম, কিন্তু এটা যদি তুমি এখন 7 দিন ফেলে রাখো তাহলে তোমার কোনো লাভ হবে না, তারা সব ভুলে যাবে। আমি তুমি বেশি তো আজকেই দিয়ে দেবো, আজকালের মধ্যে এটাকে একবার ভর্তি করবে, বুঝলে, কিন্তু ক্লাস করাটা বেকার হয়ে যাবে।
ওকে স্যার।
স্যার চ্যাপ্টার 2টা স্যার একটু দেবেন?
চ্যাপ্টার 2 দিয়ে দিন।
না স্যার,
চ্যাপ্টার 2 এ আপলোড করি, এই ডেটাবেসে চ্যাপ্টার 2 দিয়ে দিন। তোমার যখন মনে হচ্ছে দিয়ে দিচ্ছি, যাই হোক আবার দিয়ে দেবো, অসুবিধা নেই। ঠিক আছে, দুটোই আপলোড করাবো।
ঠিক আছে স্যার।
ঠিক আছে, আপনার কোশ্চেন থাকলে করো। আর কোনো কোশ্চেন আছে? আমি রিপিটেডলি বলছি, ক্লাসের সঙ্গে সঙ্গে পড়া এগোনোর চেষ্টা করো, ঠিক আছে? আদারওয়াইজ তোমার কোনো কোশ্চেনও থাকবে না, তুমি বুঝবেও না, ঠিক আছে? তো সেটা যদি করতে থাকে তাহলে তোমার কিন্তু ওই পরীক্ষার আগে গিয়ে দেখবে যে সবগুলো পড়ে আছে, তুমি বুঝে যাও।